plus non-rational functions. Remember, what we talked about so far were rational functions that look like this. Or maybe these lines moved a little bit, but essentially they look, the shape looked like that. Right? What did we call these lines again? Really? Asymptotes. Okay. Remember, those are lines that a graph will approach but never touch. Okay. All the ones we did up to now had just an x in the denominator. Okay. What happens if there's an x squared? Well, there's three cases. Okay. And the first one we're going to look at is, what if we have y equals 1 over x squared? Well, let's do a table. Okay. What's negative 2 all squared? 4, so we get 1 over 4. 1 over negative 1 all squared is 1 divided 1, which is 1. One over negative a half squared, well, negative 1/2 squared is positive 1 over 4. And remember, when we divide fractions, that's the same as multiplying by the reciprocal. So it's 1 times 4 over 1. Which gives us 4. What's 1 divided 0 squared? 1/5. 1 divided by a half squared is the same as 1 divided by negative 1/2 squared, 4. 1 divided by 1 squared is 1, and 1 divided by 2 squared is 1 over 4. So if we plot these points, we get negative 2 1/4, so about there. Negative 1, 1. Negative a half, 4. No value for x equals 0, so 1/2 is 4. 1, 1. And 1, 1/4. Okay. So if there's no value here for the graph, remember we put a vertical asymptote. So what's going to happen is as we move closer to the y-axis from the left and the right, the y values climb. Well, there's also a horizontal asymptote here, because y can never be 0. I cannot divide 1 by some number squared and get an answer of 0. It's impossible. So I have a horizontal asymptote. And like we saw with the previous graphs, as we get really, really small on the x-axis, we get closer and closer to 0. As we get really, really large on the x-axis, we get closer to 0 as well. Really, what this is this is the graph of 1 over x. 1 over x squared, you just take this and flip it up here.
and then it climbs a little sharper as well because it's squared.
I call this one the volcano.
That looks like a volcano. Okay. So whenever we have x squared on the bottom, just by itself, we're going to get that volcano shape.
Looking at some of the properties, well, the vertical asymptote, that's the line x equals 0. The horizontal asymptote, that's the line y equals 0.
For all three of these graphs that I'm going to do, this horizontal asymptote is not going to change. It's always going to be y equals 0. Okay. What's the what's the x-intercept? Yeah. Where does this graph hit the x-axis? It doesn't.
So there's not.
How about the y-intercept?
None as well. Okay.
How about the domain?
X not equals 0, because it can be, x can be any value.
Except not 0 because there's a vertical asymptote there. And the range, you sure? Look at the graph now, it's changed. It's not the same as y equals 1 over x. Lowest to highest. What do you think?
Doesn't it get really close to 0, but doesn't include? That's the lowest. What's the highest? Infinity. So we would say 0 to infinity.
We can actually use interval notation for this one. Okay. What if we have some stuff down with the x squared? Some numbers. Like this. Here's how we can graph this. Okay.
Remember, I said the horizontal asymptote. Like what we want to do when we graph these things, when we start graphing more complicated ones, do the asymptotes first, get some points around the vertical asymptotes, and sketch your graph. This is going to be the horizontal asymptote when y is 0, because I cannot go 1 divide whatever this is and get an answer of 0.
So there's no definition there at 0.
So I can say, and I'm just going to do HA for horizontal asymptote.
Y equals 0. And I'm going to put it at the bottom because I got to do the vertical asymptotes. Now remember, the vertical asymptotes
Are the values that would make this undefined, right? Because if this turns out to 0, I get an undefined and I get an asymptote. So I am looking for what values of x squared will make that denominator
equal to 0. I have to solve for that.
well. I'll move the -4 over to the other side.
And then take what?
Plus or minus.
plus minus square root.
right? So my answers, I'm actually going to have two answers. Plus minus 2. Those are actually the NPVs. So that means in this case, there's two vertical asymptotes. One where x equals -2,
And one where x equals positive 2.
so it's going to look like this.
Now the question is, where's the graph part? Okay,
Well, there's going to be a graph somewhere in here, part of the graph. There's going to be somewhere part of the graph in here because it skips over this. And there's going to be some part of the graph here.
so what I want to do,
In order to find where exactly the graph is in these sections, is I want to pick values on either side of each vertical asymptote. So if the vertical asymptote here is -2, I want to see where's the point when x is -3. So I have to plug -3
into the function.
Well, -3 all squared -4. So it's 1/5. So the point here
Is -3 1/5.
1/5. So it's going to be about here.
Now, if you remember,
My graph has to go along here and go along here. Well, if the point is here, the graph must look like this. So that's what the graph
of this whole function looks like on the left side.
What's happening inside here? Well, let's pick x equals -1. So that means I'm going to get 1 over -1 squared minus 4. So that gives me -3 on the bottom. So I get -1/3. So the next point I've identified is
-1 comma -1/3. Somewhere around there. Okay.
Let's go over here and see where the point is on the left side of this asymptote. So where x is 1. Well, where x is 1, I'm going to get the same answer. 1 over 1 squared minus 4 equals 1 over -3 or -1/3. So I get 1 -1/3.
So it's going to look like that.
Well, they have to go along the asymptotes. So this can't touch this horizontal asymptote, but it connects with that one. And then the curve continues down along the vertical asymptotes.
So you get kind of a funky looking shape. And finally, what happens in this section?
Well, go 1 on the other side of this, so x equals 3. You get 1 over 3 squared minus 4, which is going to be 1 over 5. So you get 3 1/5. 3 1/5.
Notice it's symmetrical.
I got to continue my curve along here and continue my curve along there.
So it's a pretty wild looking shape.
This one I call the erupting volcano. Because there's some lava in between. It's coming up. Learn how to spell volcano. Whenever you get an x squared in the denominator and you can factor it,
There's going to be 2 vertical asymptotes and you're going to get this shape. Okay? So just by looking at the graph, we can answer the next question. What's the behavior near the non-permissible values?
well,
Let's switch.
okay. As we approach -2, which is the asymptote on the left side, from the left, so what happens to y as we approach -2 from the left, notice y starts to climb. So y gets bigger. As we approach -2 from the right on the graph, y gets smaller. So as we ditto -2 from the right, y gets smaller. And what about the other asymptote? As we approach two from the left, notice as we approach 2 from the left, we're getting smaller. So y gets smaller. And as we approach 2 from the right, y starts to climb, gets bigger. Oops. What's happening at the ends? Well, on the left, and that as x gets smaller, y approaches 0. And on the right, as x gets bigger, y also approaches 0. Yeah, I need to move this back over here. How do I move that back? I'll figure it out. Okay.
What's the x-intercept? You can get this by looking at the graph. Where does this funky looking graph touch the x-axis? It doesn't.
No, it doesn't touch it at all. So no x-intercept. There is a y-intercept.
But it's really hard to see, isn't it?
You sure? How'd you get that? Because you assume this was negative a third, this was negative a third, it goes straight across.
I mean, it's a good guess. But it does go a little bit higher. Okay? But you're along the right track.
It's somewhere, it's a little smaller than negative a third. Well, if we can't get it from the graph, we have to do it using algebra. So for the y-intercept, we gotta make x equals 0 and find it. Y equals 1 over 0 squared minus 4, which is what? Sorry? I'm hearing mumbling, that's all I'm hearing.
What?
Thank you. Heard that one.
Negative 1/4. What'd you put for the domain? It can be everything except what?
For the domain. 0? Oh, it can be 0. You're thinking range. What's the point to the furthest left? Negative infinity goes off to positive infinity, but it doesn't hit two x's. Where? Here and here. There's no point on the graph here. So I would say it can be everything except negative 2 and positive 2. So I would say x not equal to negative 2 and positive 2. So that's what happens when you have a number down with the x squared that you can factor and get two asymptotes. What happens in this final case? We got an x squared on the bottom this time. Sorry, we got an x squared again on the bottom, except this time we have a plus 2. Well, like I said, that's not going to change. Horizontal asymptote is y equals 0. Oh, what about the vertical?
What value of x can I plug in there and then do x squared plus 2 and get an answer of 0?
What number could you plug in here? And then add 2, and it equals 0. Give me a number to try. Pick a number. Pick a number. Sorry? 10? 10 squared is plus 2? That's not 0. Pick another number. 3 squared plus 2 doesn't equal 0. I'll wait. Okay, you tried positive numbers. They don't seem to be working. Thank you. Negative 2. Negative 2 squared. 4 plus 2 doesn't equal 0. Doesn't seem like any negatives work. Doesn't seem like any positive works. This is impossible. You can't solve this. Because think about it. If I move the plus 2 to the other side, I get negative 2. And then I take the positive and negative square root of negative 2, but you can't do that. So there's no solution. Which means there's no vertical asymptote this time. Which means I can't really do this. If there's no vertical asymptote, I can't get any points around it. So here's what I would suggest you do. Because there's no vertical asymptote, let's see what happens around here. Let's see what happens around the middle. Okay. So let's do x equals -1, x equals 0, and x equals +1. Well, what do I get? 1 over -1 squared plus 2 gives me a third. So -1, 1/3. If x is 0, 1 over 0 squared plus 2, that gives me a half. So slightly higher. So this is -1, 1/3. This is 0, 1/2. And then if I do 1, I get 1 over 1 squared plus 2, and I get a third again. So 1, 1/3. So it looks like that. Well, we know that it has to continue on here along the horizontal asymptote, and then it kind of goes up a little bit, and then it continues along there. I call this one the speed bump. There's a little speed bump thing. So what's happening near the non-permissible values? Well, there are no non-permissible values. So nothing's happening. What's the end behavior on the left and the right? Well, as x gets smaller, y keeps getting closer to 0, but never touches it. As x gets larger, y does the same thing. It approaches 0, but never touches it.
What's the x-intercept? Look at the graph. You should be able to tell me. Where does this graph, the speed bump, touch the x-axis? Nope. X-axis. You just found me the y-intercept.
No x-intercept, yes. What's the y-intercept?
Somebody said it.
1/2, good.
What's the domain? Negative
Infinity to infinity. Well done.
Okay. We're going to continue to look, like the thing with rational functions is that there's so many different ways the graphs could look. It all depends on if there's exponents in there, where the x's are, how many x's are up top and on the bottom, where numbers are, everything.
Delete the recording.